myself Dr. Divya, Assistant Professor at the Department of Chemistry, Institute of Analytical Engineering. So today we will discuss the topic electrochemistry. The next where the batteries are explained. It will the outcomes of this session would be the understanding of concept of batteries, the classification and application. So here are the topics: introduction to batteries, the batteries introduction, the history of the batteries, then classification of batteries. The batteries are classified variously depending on chargeability capacity. Then primary batteries are the cell and their working and applications with an example. Then secondary cells are lead acid battery with an application oriented working and its applications. Then lithium ion battery, its working and applications. So we will go into the introduction topic wherein we will understand what is a battery, how the battery is made up of. So this device consists of two or more galvanic cells. As we have studied in the previous session, what are the galvanic cells? Those cells are connected together, two or more, to increase the voltage, forming a battery. So it can be either series or in parallel mode or in both the orientations, and this will give high potential for running any automobile or any other applications. So what does this battery contain? This battery contains a chemical material. So this chemical material will convert into an electrical energy. So this electrical energy is used for the applications. So depending on the device, depending on the applications, there are different devices like with size and design with respective different applications. So what is the anode and cathode? So this is an example of a battery. So what does it contain? Anode material and a cathode material. The anode material, their oxidation takes place, and at cathode, reduction takes place. There is also a separator. It has a separator that will avoid shorting of the battery. So it also avoids the electrical contact between two anode plates and cathode electrodes. So avoids shorting. So this is very important. So a separator is important to avoid shorting of the device so that it smoothly runs. Then electrolyte. This electrolyte is a conducting substance, moves between these two electrodes. Electrolyte moves between anode and cathode. So we will see in detail how the classification or the history. This is a type of battery. Why and when is it introduced or invented, and then how the development has taken place. So this is the history of battery. So first cell is manufactured or discovered in around 200 BC. So these are first batteries that are being used in around 200 BC. So then in 1749, Benjamin Franklin lost a battery while linking capacitors. Then about 1800, Alexander Volta stacked copper and zinc with a cloth separator drenched in salt solution that acted as a battery. So these are some developments. As we can see in the figure 2, the copper, this shows the Volta pile, wherein the scientist has piled up copper and zinc with a cloth separator in the salt solution, forming a battery. So we will see for the next development. In 1859, lead acid batteries are developed, and in 1899, nickel cadmium batteries are developed, and in 1889, nickel metal hydride. So with this, there is a huge development in the batteries history. So as we see, we have come to a solid state battery. The ultimate one is a solid state battery for the present generation. So we will see how the different batteries vary in their configuration and the working principles. So there are different types of batteries, primary cells and secondary cells. So these primary cells and secondary cells are clubbed together to form some batteries. Primary cells to form a battery and secondary cells to form other battery. So chemical batteries, they are also called chemical batteries. The primary batteries examples are magnesium batteries or alkaline batteries, which are discharged only once. It means it is used as long as the active material is present in the cell. Then secondary batteries which can be reused upon charging. So these includes lithium ion batteries, lead acid batteries, etc. So the other one are the fuel cells, physical batteries and biological batteries. These are the advanced ones, wherein hydrogen fuel cells are some of the examples for fuel cells. Then ethanol fuel cells. Then physical cells are like solar cells and capacitors, supercapacitors. Then biological cells are biological solar cells and biological fuel cells. So with this, we will go into the details of primary batteries, how they are developed. The potential of a battery is to use the free energy of active material as long as present in the battery. This forms the primary battery. This forms the primary batteries. So it has some active material or the compound wherein chemical reactions takes place. That is the redox reactions that takes place, and as long as the reaction takes place, there is charging that is being used. I mean, the discharge is happening that can be continuously used for the applications. So these cell reactions are not reversible. So irreversible. It means the reaction cannot be there is no backward reaction and cannot be recharged. So examples are dry cells like zinc manganese dioxide cell. So we will see in detail how the development happened for the dry cells. So dry cells are invented in 1860s, which is commonly called as a Leclanche cell. The common name is dry cell. So it is also called Leclanche cell. So this is the schematic of a dry cell. Schematic of a dry cell. So it is mostly used for the household applications like TV remotes, clocks and other devices. So these are most widely used for household applications. So in such cells, what happens? The zinc container itself acts as an anode, and then the carbon rod acts as a cathode. So this container in the gray color is a zinc, made up of zinc. So zinc is acting as an anode, and the black one is the cathode. So this cathode is nothing but the carbon rod that acts as a cathode. So then a powdered mixture of manganese dioxide and carbon is placed around the cathode. A powder of manganese dioxide and carbon together is filled beside the cathode, that is also called as cathode mix. So here is the mix that is filled just after the carbon rod. So the space left between the container and the rod are filled with moist paste of ammonium chloride and zinc chloride. So this is also called as electrolyte paste, which is filled in between the container and the rod. Between the container and the rod. This pink one is the electrolyte paste that is filled between the carbon rod and the zinc container. So we will see how the working would takes place. These are various reactions that will happen. So the redox reactions. So when the battery is dismantled, as we see in this figure, the battery after dismantling, the outer cover is stainless steel. However, this is the zinc container. This is the zinc container. So the redox reaction that takes place are at anode. At anode, what happens? The zinc, the container zinc, as we know, it is highly reactive. It will oxidizes and forms Zn2 plus ion and gives off 2 electrons. This is the zinc container. And at cathode, what happens? These 2 electrons are consumed by the cathode mix, that is ammonium, and forms ammonia and hydrogen gas. Then this ammonia will combine with zinc plus 2 ions and form a complex, that is zinc ammonium complex. Then the hydrogen that is evolved will react with manganese dioxide and form manganese oxide and water in aqueous state. So these are the reactions that takes place at anode and at cathode. cathode. So the overall reaction will be like, upon balancing and combining it anode and cathode, the overall reaction will be like zinc plus ammonia and manganese dioxide will give rise to this complex, and then manganese oxide and water. So the potential of this cell will be like around 1.5 volt. So therefore, as the potential is very low, the E cell is low, these are used for smaller applications that requires less voltage. Okay, so this is the reaction, that is irreversible reaction, that is taking place during the usage of dry cells. So these are the wide applications that are used, wherein TV remotes, clocks, calculators, child toys, and lights, flashlights. So these are some of the examples of applications. Then what are the advantages? They are inexpensive and safe and available in many sizes, as we can see in our daily usage. Like they are pencil size and also bigger sizes, so they are available in different sizes depending on the toy. For example, if you are using for the toys, depending on their size also there is a variation in their battery size. So what are the disadvantages? At high current, when we are using for bigger application than the voltage that is available with the batteries, there is a buildup of ammonia gas causing to the drop in the voltage. So when the voltage is dropping, what happens? The shelf life will reduce, and the zinc anode reacts with acidic ammonium ions. So this is the reaction that will take place and will cause bulging of these batteries. Then what are the secondary cells? Secondary cells are rechargeable cells. It means the cells or the batteries formed from these cells can be recharged and reused again and again. So batteries are rechargeable. Then the cell reactions are reversible. It means the reactions whatever are taking place during usage can be reversed back so that it can be charged. So these are called reversible batteries. And this cell can operate as both a voltaic and electrolytic cell. So as we have already seen what is an voltaic and electrolytic cell, this is like as a voltaic cell, it supplies energy. It supplies electrical energy, that is during discharge, and becomes run down. As long as we use, the energy will be drained off and is called as rundown. And as an electrolytic cell, it receives electrical current or the electrical energy during charging process and stores in the battery. So some of the examples are lead acid battery and nickel cadmium battery. See, as we see from this diagram, this is lead acid battery that are mostly used for our automobiles. So this, as we see, this is a bigger battery with lead acid cells that are connected in series. So we will see in detail how the construction and working takes place. So this is the construction of lead acid battery. So for example, this is mostly used in automobiles and inverters for the UPS connections, and they can be recharged for a limited number of times. So the lead acid storage battery consists of a lead anode, that is the negative terminal, and the cathode is a lead grid packed with a lead dioxide. So both the anode and cathode are separated by insulators. They are separated by insulators like glass, fiber sheets, wood, or rubber. These are the insulators that are used to separate the anode and cathode material. Then the lead plates fits in between the lead oxide plates. So one plate will be lead, and the other plate will be lead dioxide. So they are connected in series, as we see from the diagram also. So this red one is the lead dioxide plate, and the blue one is the lead plate. So this in between, it is filled with sulfuric acid with a concentration of 38%, which is used as an electrolyte or the medium for the reactions. So the oxidation reduction reactions takes place during the charge and discharge process of this battery. So what happens at the discharge? So discharge is nothing but the usage. Whenever we are using the battery for our application, it discharges. So what happens at anode and what happens at the cathode? So lead that is present, the lead rod plate, this is the anode. This is the anode. So what happens? The lead is oxidized to lead 2 plus ions, which further combines with sulfate ions from the aqueous sulfuric acid. So what happens? This lead is converted to lead plus 2 ion. Lead plus 2 ion and combines with the sulfate in the sulfuric acid and forms lead sulfate So this is the reaction that is taking place at anode. So what happens at the cathode? The electrons released from anode. So there are 2 electrons, as we observe here. There are 2 electrons that are released from the anode. So the electrons released from the anode flows to the cathode. So flows to the cathode. As we see from the diagram, the electrons are flowing through the circuit to the cathode. So this PbO2, that is lead dioxide, gains 2 electrons to form Pb plus 2 ions. So it is it is changing its oxidation state. That lead is changing its oxidation state from plus 4 to plus 2. It is reduction. So reduction is happening. What is happening here? From 0 state to plus 2 state. So oxidation is happening. Here reduction is going to take place. So the lead plus 2 ions combine with sulfate ions again present in the aqueous sulfuric acid. It combines with the sulfate ions and forms lead sulfate. The overall reaction is same, like it will form lead sulfate both at anode and cathode. However, the lead plate and the lead dioxide plates are placed so that it undergoes oxidation at anode and reduction at cathode. So ultimately there is a formation of lead sulfate in both the cases. So the overall reaction will be lead plus sulfate ion. So it is minus sulfate 2 minus gives lead sulfate plus 2 electrons, and again at cathode lead dioxide plus sulfate ions. It will accept these 2 electrons and the sulfuric acid from the electrolyte and forms lead sulfate and water. So ultimately what happens? From this overall reaction, energy is released. See, this energy is used. For applications. So both at anode and cathode, lead sulfate is deposited. So what happens when we are using continuously? This lead sulfate keep on depositing on anode and cathode. So this will ultimately stop working. So what happens when it is stop working? The recharging should be done. Recharging of the battery has to be done. It is done by applying voltage across the electrodes, which is greater than 2 volts. Why we are applying greater than 2 volts? Because each cell produces 2 volts of E cell. The E cell of this cell is 2 volts. So we require higher than that to recharge the cell. So the current will flow in opposite direction that of battery can deliver. So during charging of the battery, what happens? This is the charging, that is we are supplying electrical current. So at anode what happens, and at cathode what happens? At cathode we will see in detail. Like lead 2 plus 2 ions will consume 2 electrons to form lead. So it will consume 2 electrons. This is anode and this is cathode. So it is consuming 2 electrons from the electricity current, that is flowing electrons, and it forms lead in 0 state. The metal will be regenerated. At cathode what happens? The lead sulfate reacts with water and gives off electrons and lead oxide. As we know, that we will be filling water for the lead acid batteries. So this water will help in regenerating the lead dioxide. So the overall reaction will be like lead sulfate plus water plus energy. We are supplying electrical energy here, electrical energy, and it will form lead and lead dioxide and the sulfuric acid, that is the electrolyte for the whole battery. So here it is acting as electrolytic cell during charging. Then what is the maintenance that has to be done for a lead acid battery? If the lead acid batteries are properly maintained, they can be used for longer periods. So we have to avoid over discharging of the battery. We should not keep the battery running for until the material is being used or the deposition is too much for the electrodes. Then maintain the electrolyte at proper level. There will be a level for the electrolyte in the battery, so we have to maintain that level. So as we see from this figure, here the mechanic is spilling water into the battery so that it will maintain the electrolyte level. Then keep the battery clean. So brushing the battery is very important. Like we have to clean the battery with brushes so that the terminals are not corroded, and keep it clean so that it can be worked for the longer periods. So the uses of the battery, if we see, applications are like wide applications in cars and buses, automobiles. Any automobiles will be using lead acid batteries since decades. Then it is also used in gas engine ignition, telephone exchanges, hospitals, UPS, uninterrupted power supply. So and these are some of the important applications. As we see from this, there are also some telecom towers, then solar power, where the energy can be trapped into the batteries and can be used during nights. Then wind power, any power that is generated from natural sources is only available during daylight, which are using daylight, or only when the resource is available. They can be stored in the batteries and used when there is no resource or the daylight. So next are the lithium-ion batteries. The secondary cells also contains a lithium-ion batteries, that is advanced batteries. So this is also a rechargeable battery. Why we have to really consider the lithium-ion battery? Because it has very good specific energy. See, as we see from this plot, lead acid battery is lying below. It means it has less specific energy and less power. And we always prefer to work with better specific energy that can deliver and with high power. So that is why the lithium ion came into existence. And why we are not considering the lithium metal? Because it is highly reactive, so that only lithium ions are taken for the applications. So we will see in detail how and why the lithium ion and the lithium metal is considered. So lithium ions, the reversible reductions of these lithium ions will help in storing the energy. As we know, the lithium is the lightest of all metals, so has greater electrochemical potential and provides high specific energy per weight. So it also helps in forming less space. It can occupy less space and also has high specific energy that can be used for wide applications. So these properties make lithium the potential to achieve high energy and power densities in high density battery applications such as automotive and standby power. So as we see, this is the battery that we use. This is the lithium ion battery, an example for the applications. So let us see the construction of lithium ion batteries. What happens? Like there is an anode and a cathode. So anode is a carbon compound or graphite. Anode is a carbon compound or graphite that is used. So this is highly inert. Then cathode is lithium oxide or any lithium compound. So lithium oxide that is intercalated. Generally, it is intercalated. It means we will see in detail like intercalated in the graphite. So we will see how it will be working. Cathode consists of a graphite into which lithium oxide is intercalated. So like this, it forms a battery. So then the wide applications are laptops, cell phones, electrical vehicles. All these are the advanced techniques, advanced vehicles that are developed with lithium ion batteries. So the electrolyte, it also has an electrolyte, lithium phosphate fluoride and lithium borofluoride. So these are the electrolyte. Generally, organic solvents are used for the application in the lithium ion batteries. There are some membranes such as microporous membranes that are used as a separator. So what are the membranes used? Polyethylene is used to separate the electrons from ions. So that is also preventing the shorting of the device. So this intercalation, what I said before, is the intercalation. For example, if we have carbon chain like this in the graphite, there will be intercalation in between lithium ions are present. Lithium ions are present. So these are intercalated in the interstitial spaces of the graphite sheets. So this will keep the smaller ions in the interstitial spaces of the graphite crystal. So this graphite crystal contains lithium ions, that is, they are active in moving. So these are some of the reactions that will take place. So let us see the discharging reaction. What happens at the discharge when we are using the lithium ion battery in the application. So during discharge, an oxidation half reaction at the anode produces positively charged lithium plus ions and negatively charged electrons. So what happens during discharge? There are production of positively charged lithium ions. Positively charged lithium ions are produced. So and negatively charged electrons are produced. So these lithium ions will flow through the electrolyte. Lithium ions will flow through the or move through the electrolyte, and electrons will move through the external circuit. Electrons will move through the external circuit. So as we see, here the electrons are moving through the external circuit. So, and they recombine at the cathode in the reduction half reaction. Here is the cathode. These electrons will recombine here. So, during discharge, the electrons from the anode to cathode flows through the circuit. That is an important point where we have to consider. The electrons will move from the anode to cathode. Anode to cathode. So, at cathode, the cobalt oxide will combine lithium ion, and the electrons will combine and form lithium cobalt oxide. So these are the compounds that will be forming, and then at anode, lithium intercalated in the graphite will give lithium plus electrons. As we have seen previously in the above, lithium and electrons, and the graphite C6 is graphite as such. So the overall reaction will be lithium in the graphite plus cobalt oxide will give rise to lithium cobalt oxide and the graphite as such. So these are the reversible reactions that are taking place. So what happens during discharge? It will be from the reaction will be from left to right, and during charging it will be from right to left. It means the lithium cobalt oxide will again convert to cobalt oxide and lithium in the graphite. So these are the reaction that will take place. The main important thing is like these ions, the lithium ions will flow through the electrolyte. These lithium ions will be flowing through the electrode from anode to cathode and cathode to anode, so that the cell will keep working. So these are the main principle that a lithium ion battery works. So what are the applications? The main applications of lithium ion batteries are portable devices that we are using daily, like mobiles, laptops, digital cameras, then electronic cigarettes and torches, etc. So as we see from this chart, this is a widely growing market. There is a lot of market for the lithium ion batteries. So these are like saturated So we are already using for that smartphones, laptops, tablets, power tools, and personal care materials and all. So these are already we are using. However, there are trending applications in all these like cars, buses, forklifts, and automobiles. So power tools, example for the power tools are like drills, saws, garden equipment wherein there cannot be electricity gauges. So garden for these the batteries can be used for high power. Then electrical vehicles like electric cars, buses, forklifts, and auto bicycles. So auto bicycles, all these have wide applications. Now there is a potential market for lithium ion batteries. So as we know that there are solar energy that is being converted into electricity. So the grid energy or the photovoltaics has wider applications for batteries and supercapacitors, especially lithium ion batteries wherein it can be stored. See, as we see, the renewable energy that is generated during daytime can be stored in these batteries and can be used during the nights. So these are the very important applications for lithium ion batteries. So what are the main advantages and disadvantages? It is lightweight. Advantages are lightweight and then have high energy density than other rechargeable batteries. It has very good energy density as we have seen in the plot in compared to the nickel cadmium and lead acid batteries. Then rate of charge loss is less, then has high number of charge and discharge cycles. So before any application of a battery, we generally test at lab scale the charge and discharge cycles. So this has got very good charge and discharge cycles with a great number that can be used for a longer time and need not be discharged completely. So this battery need not be drained off completely. So to recharge, even if there is 1 or 2% of charging, we can for example like for mobile phones we need not wait until the charging is zero. So even if it is 20%, 10%, we keep on charging the mobile. So that is what we need not discharge completely. Then operates at high voltage than other rechargeable batteries. So it has got very good voltage so that it can be used for higher applications like buses and cars. Then disadvantages involves bursting. So when there are unusual reactions that takes place, it can cause bursting. Then costly compared to other batteries. It is costly when compared to other batteries due to which lithium metal that we are using, that is a scarce metal in the earth crust. Then also the cobalt. Complete discharge damages the battery. So as we know that we generally don't discharge the batteries completely because it will get damaged. Extremely sensitive to high temperatures. So as we again an example of a mobile phone, if we take when we are using in sunlight, daylight, when it is getting heated up, the phone will hang up. It means it is very sensitive to high temperatures. Then a very short lifespan and not available in standard size cells. It means for smaller applications and all, some standard sizes are not available. So these are some of the disadvantages. But however, when we look at advantages of this for larger applications, we generally prefer lithium ion batteries because if we produce e-cars or e-buses, that will reduce global warming as no pollution. Pollution will be reduced. So with these advantages, we use lithium. We prefer, and there are a lot of research going on lithium-ion batteries for advancements. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.